Hello and welcome to this webinar with Aaron Kessler and Jeff Dieffenbach titled The Science of Learning. We are also joined this morning by Dr. Claudia Urrea, Associate Director of PK-12 here at JWell. I'm Steve Carson, JWell Associate Director for Membership Management, and I'll be moderating today's webinar. Aaron Kessler is a Senior Learning Scientist for the Office of Open Learning. Aaron has experience engineering instructional opportunities for students across numerous settings, including K-12 science classrooms, face-to-face higher education courses, hybrid courses, online-only learning environments, and informal education. One area of his work is focused on how to prepare educators to integrate technologies into their instruction. Jeff Dieffenbach is Associate Director of the MIT Integrated Learning Initiative, also known as MITLE. Prior to joining MIT in that role, he worked in strategy, product management, business development, sales, and marketing roles for a range of traditional and digital educational companies. Jeff has master's degrees in technology and policy and in materials engineering from MIT. In today's webinar, Aaron and Jeff will introduce the idea of science of learning and share specific findings. We'll discuss where you have delivered or seen examples of these findings and explore how they might be used to create future learning experiences.
So this is Jeff speaking. Aaron?
Hello, everyone.
And we're going to talk through the science of learning and specifically some select findings. It's a rich field with hundreds of thousands, if not more, academic papers in the subject. We're going to extract a few key findings and then have some conversations about how you've seen them apply or how you might apply them. We're going to frame the science of learning with a look at the kinds of questions that can be asked. We can think about how differences in the learner, differences in instruction, and differences in policy affect learning outcomes. When we think about the learner, for instance, we might look at how prior knowledge or motivation or interest or physiological readiness affect a learner's ability to learn. On the instruction side, we can look at differences in content, delivery, and assessment. And with policy, we can look at differences in law, access to education, funding, leadership, and broad-scale measurement. And we represent these three areas with an overlapping Venn diagram because you can study them at one, two, or all three of those levels. And that's one slice through the kinds of research that can be done. A second is the demographic of the learner that's addressed, a pre-K-12 learner, someone in higher ed, or someone in the workforce. We're going to start with a slide that talks about the multi-store model of memory and learning. Ultimately, memory is the essence of learning, that is the ability to get things into and out of your memory. We can start with some sensory input, which falls on some sort of sensory receptor, our eyes, our ears, it could be touch or taste or even smell. Now, if that's not retained, it's as if we haven't attended at all to that learning. The next step is to get it into short-term memory, but we may not store it long-term. Ideally, we'd like to get it into long-term memory, but even there, we may not remember it. We may not be able to bring it back when we need it. So what we're really looking at, this loop represented by steps 3 and 4 here of reinforcing the transfer of information from short-term memory to long-term memory and back. What that really means is that learning is overcoming not remembering. There's a classic study by Ebbinghaus that looks at, on the vertical axis, how much of what you learn you retain and how that decays over time. So we can see that even a day later, we're less than 40% of the original retention. And we're going to come back to that about ways that we can help overcome that. So let's talk a little bit about a few science of learning findings, and then we're going to break out into some virtual discussion groups to reflect on them. The first thing that we'll talk about is spaced learning. This is a meta-analysis of several hundred studies and almost 15,000 participants. And we're looking at two kinds of spacing of learning. One, learning is essentially uninterrupted. We may learn something and learn it again with essentially zero lag. We can also look at spaced learning, where the spacing could be relatively short, measured in seconds to days or more. So what this chart shows, again, the percentage correct or how much we've learned or retained on the vertical axis. And the groupings going across the x-axis are the time between learning and testing. So 2 to 59 seconds on the left edge of that means the test is almost immediate. 30 plus days out on the right edge means that the test is at least a month later. And for each of these gaps between learning and testing, we can look at the spacing of learning in between before that test. So what we're seeing here is that roughly it doesn't matter how much you space out learning. 1 second gap or a 10-second gap is represented by the dark red line, 11 to 30 seconds by the orange line, and so on. But what we'll find is as the time grows between when we learn and when we test, that spacing starts to matter more and more. And we can represent this by the slope of these different lines. As in essence, the longer we go between learning and testing, the more it helps to have our learning spaced out.
So, and something to remember here as you sort of look at this graph is the idea here is that, you know, where is the learning occurring in this, right? So it's a learning initially and then sort of times and opportunities to learn in the middle between then and sort of that opportunity to test. So the idea here is that if you've got opportunities in terms of spacing between initial learning and testing, it makes sense that you want to come back to opportunities to learn in the middle of that, as sort of represented by the graph.
We can revisit Ebbinghaus and see exactly why that works and how that can benefit us. Let's take our 1-day example. It's a day after I've learned something. If I learn it again, I, in theory, pop my retention back up close to 100%. It's going to start to decay again, but maybe a week later, I learn it. And we can repeat this process. Eventually, learning becomes automatic if it's something that we're using all the time. In essence, it means that we're constantly getting spacing and reinforcement. And so that's what we want to try to do with learning. Now, an interesting thing about the spacing is what do you do in between? In particularly formal education, it may not be practical to send students away for a day or a number of days. And the concept of interleaving can help us with that. Spacing and interleaving go very nicely together. So to explain interleaving, we'll use an example of participants learning the formula for the volume of 4 different types of solids. And there are going to be 2 groups with different sequences of practice and being tested. The first group are the blockers. So they're going to see 4 chances to work with and practice the formula for a sphere. And then next they'll do some rectangular solid and a pyramid solid and some other solid shape. By comparison, we've got a group called the mixers. So the mixers will work on one of those shapes, then a different one and a different one and a different one, and then repeat that cycle. So overall, you can see that they're getting the same amount of practice and exposure to the content, but how they're interleaving that content is varying. And so the way this works, again, we're looking at percent correct on the vertical axis. In our practice, which is shortly after our learning, the blockers perform a bit better than the mixers. But on a test that might be a couple of weeks later, we see that the mixers do much better. And that's a testament to the value of interleaving as a way to make the learning that you're doing a bit more novel and to add spacing into your learning.
So something to remember as we sort of move into facilitating a little bit of a discussion is to think about the implications that these sort of results might have in the way you think about the presentation of curriculum and materials within a section of a course or within a whole course or across courses. So this idea of sort of thinking about, well, how are we spacing opportunities to experience specific things related to a learning objective or goal? And then also, how are we sort of interleaving those opportunities across multiple interactions? So I think Jeff sort of pointed out nicely so that this idea of spacing and interleaving really sort of go hand in hand and probably can have a drastic impact on the way you think about changing or altering a curriculum.